Hey guys, let me know if the microphone is good. Actually, where was it? Here? Pulse audio? Wait, let me check it. Jesus Christ. That's, no bueno. Why is it default to this here? Back to pulse audio. Oh god. I'm so sorry. Is that good? Oh, that's okay. That's wonderful. In fact, I'd say that's what we want, but I'm not sure what the other thing was. It's not over here. Whoa. Hopefully that's good. Hopefully it's not like fucking exploding because of whatever fucking reason. Duplicate, copy, and paste. Bruh, make this thing global, bruh. I'm telling you, man. Copy it and paste it. How do you do this? You just hit Control C. You go over here. No, Control C, Control V. Copy and paste. Wait, what? I can't? I pseudo can't copy paste? Copy paste it. Bruh.
Figure it out. You can kind of add a Debian for your main driver and dash sensor or something like that. 500 audio. I've actually been working on this.
So, it's been getting closer and closer. Closer and closer to us having a functional audio. Is that good? No, like, weird clipping or anything? Bro, you straight up... Oh my god, the bitrate be bad on this one? This one's bad? I can't hear it. Bro, it sounded like 8 bits. Yeah, that's fine. Wait, but on this one it's good though. This one sounds good. What's wrong with this one then? This one's bad? This is called engineering. Figuring out what the problem is until we... I think it's just clipping. I think that's what it is. It should be good like right about there. Hello? This is good? You fixed it because you set it to another audio input? Oh, okay. Okay, so this is good. Set it to default and then listen to it. I mean, I'm able to hear it, kind of, but my voice is loud, so I'm guessing it's fine. If it's not fine, then just let me know in like 5 minutes. I'm sure we'll figure it out. So we're gonna be doing some stuff today in Flatpak Brave, bro. Get out of here. Stop showing off that I don't know how to set up Pipewire because I'm dumb. Bro, me being so lame I can't set up Pipewire, bro. But we need to do some stuff on my project, so we need to go read about NASM today. I was reading about NASM yesterday. It's pretty cool. It's very important to learn. Also need to go read about my RAM real quick. Or about some RAM real quick. Maybe not my RAM. World's greatest hydration. Live hydration stream. Wow. AMD AVX 512. Wow. 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 Dash F option. F to pay respects. I'm on page 35, but we'll go reread through it. Since I already get NASM, TASM compatibility mode, T assembler is like T series. The T series assembler. T series versus PewDiePie assembler. What? Oh my god, bro. copy the link so I can watch it in another tab, bro. So it doesn't close out on me, bro. Here I am trying to figure shit out. Trying to do some live programming, bro. Opened up my docs and then was like, yeah. Alright, I could check out how the audio sounded earlier. What's the, where's the other one? There we go. How's the audio sounds to me? Stop that. Okay. Brilliant day. Cool. Docs time. Time to read some docs. The -gl prefix, bruh, everybody hates GL. Everybody should hate OpenGL. It's the shittiest thing of all time. Quick start for MASM users, or with TASM and MASM compatible. Non-ideal mode. Non-ideal mode, bro, that's cool. NASM requires square brackets for memory references. There should be a section where they just go over like NASM and just how to use it. It's like in like the page 35, NASM language, layout of the NASM line. You got label, instruction, and comment. Pretty cool, right? Pretty much what we're gonna try to do today is get to our boot header from scratch, because I forgot how to get us to the multi-boot header. So we're gonna begin working on Fish OS today, hopefully. And I'll probably make a video where I go over more of this in detail. There's a lot of stuff here because I'm not gonna read over all this. We're just gonna get like the basic label, instruction, comment. And then there's also stuff about identifying different things, like some things you can refer to them like this and it means a thing, or like you got one symbol called this. It's pretty much like prepending a underscore to a variable because you have another variable of the same name, which really doesn't happen that much if you know what you're doing. And well, for me at least, it doesn't happen much. I don't know, I've never really had that problem. Continuing on is the pseudo instructions, and then this is where we get into like the DD thing, which is just to declare initialized data in the output file. So essentially like a variable almost. A question mark argument to declare uninitialized storage. I'm assuming that means that it will be eventually used at some point. So like you start off uninitialized and then you would assign an evaluator, for lack of better words. I doubt it's called assign, but maybe. Maybe I'm right. A superset of the dupe syntax, the NASM version. Now this is stuff I haven't read, so I don't really know too much about all of this, and so it's going to be good for me to learn this right now, so that way if I do go make a video about it for the videos I plan to make, then yeah. Even though yesterday I just spent all day troubleshooting, trying to get that done. I mean, I didn't really spend all day, but I spent all my free time troubleshooting, bro, just to get the audio to work. DD question mark, which is initializing nothing, like unknown, uninitialized, yeah. Dupe, is dupe a, doesn't really describe what dupe is. I guess it makes a dupe of 32 and then something like that. I don't know. Stuff. Really not the most important things, although it is important. You need a header, you need a DD, a couple lines of DD. Resb is also important. Reserve B. Essentially, you'll use these for something in the multi-boot header as well. Resb, resw, resd, resq, rest, so resy, and resz. Resb reserve 64 bytes. Yeah, we'll need to resb for 16 kilobytes. So we need to do resb 16,000 or something along those lines. So let me just open up my locate. So I remember that we have to reserve B for something like that. We also need to have a global header. The global is the entry point when you get to the linker. So you have a global start or something like that. So we'll make a new file. I'll zoom in real quick. So we'll call it like global start or something. Global. I don't think you capitalize it. You just do like global start. I'm not even sure if I've gotten that far. But that's like when you get to the linker portion, you need to have it like that. Just so I can remember that. And then maybe we need to have res b already just written out, so that way I remember that we need to res b 16 kilobytes, something like that. These are just notes for me when I get to them, when I actually get to building it or making the thing work. Res b, and the reason you need 16 kilobytes is for, I actually don't know. It was something for the, no, it's for the stack size. That's important for stack size. EQ, defining constants, times, repeating instructions. Oh, so you could use times to do an instruction multiple times in a row. What if you could do that with uninitialized variable or uninitialized values? Defining constants. Oh, right. EQ defines a symbol given a constant value. EQ is used. The source line must only contain a label. Right, these are actually important. So the first thing we would do is we'd have our... Oh, let's go back, because I have a page open that has a lot of information on multi-boot specifications. Magic, flags, and checksum. Those are the three things I'm going to need. So the magic is the magic, and then we'll need magic's going to be a label. Then you assign EQ for a constant, and then, or you'll use the EQ for a constant. Bro, here I am looking dumb. And then after you do well, actually, isn't it caps for EQ? What does it look like again? Bro, was it caps? I swear it was. Never mind, it's lowercase. But yeah, you need EQ for constants equals. Nice. And then after we have our constant for our magic, we need to put in the, what is it, 0x0 bad bootu, bro. Yeah. Oh, it's 0x1 bad bootu. Never mind. But that's what allows grub to boot this. This is a multi-boot header. I just remember it as bad bootu because Ubuntu sucks. Something like that. Is it actually bad bootu, or am I dumb? No, it literally is bad bootu. Fucking bad bootu. Yes, and bring me back to my Ubuntu hater tab. My Ubuntu hater arc, bro. Damn. Thank you. Thank you, NVIDIA. I love NVIDIA, guys. Alright, so we got our bad bootu line. And then if you want to add a comment, you put a semicolon at the end of that. Although I'm not sure how to end the line. I think you just go into the next line. So we got that. And then we have our... We'd probably do like we'd have a header for this, and we'd be like, something to do with that. And then the res b is the 16 kilobytes. You could also just make a constant for it, I guess, to have 16 kilobytes as a constant. The goal at the end of this is to have us get into 32-bit protected mode, which is also important. Which, if you want to learn about the architectures, then just go into this book here. The link is right there. For those wondering, just search up AMD architecture, or you could read the Intel architecture, and it will probably talk about the same shit. I mean, AMD and Intel are the only ones really making CPUs that are anything anyway. Unless there is, actually, there ARM chips, technically, you could read about those. Scroll down to like page 60, preface, and then you get into like memory stuff. This is more hardware side, more of the hardware and the technicalities of the CPU itself, rather than like actual instructions, because the instructions are different depending on your assembler. So memory addressing, logical addresses, there's stuff to do with like all of this. There should be a table here though of the different modes that you can get into. And scrolling down. Oh, here it is. No. Operating modes, you have your 64-bit mode, your compatibility mode, which that's long mode 3. I have not really messed around with getting into the 64-bit mode, but I've gotten into the 32-bit mode before, and all you have to do to get into legacy 32-bit protected mode is cook. Literally just be a multi-boot header and code that runs. So as long as it's not high level code, it can probably do it. So we need our magic, we need our checksum. Bruh. Now I need to zoom out again. I kind of like my formatting to look semi-decent. Anyway, back to it. Checksum, and then magic. Which I don't actually know what checksum equals. What I do know is that you also need flags as well. Equals. So those are the 3 things we're gonna need so far. Let's go back to the multi-boot specification and see if there's any information on here that's useful. The layout of the multi-boot header. So the first thing it has is, oh yeah, you need to work with alignments too. That's important. Alignments are very important. So the magic, flags, checksum, header addresses, load addresses. Some of these are not required. The first 3 are mandatory if you're gonna even try to get it to boot. The other stuff's for like magic, fanciness. I don't know. I think I went in the correct order too. Did I actually go? Bro, I actually went in the correct order. I think in one of the tutorials I read, you had to align stuff. Like when we did it a couple, like what was it, like a month ago? You had to align stuff weirdly. Anyway, moving on. The address fields of a multi-boot header. The address fields are enabled by, a flag enabled by our 16, or flag bit 16 address. Contains the address of the beginning of the multi-boot header, contains the physical address, the graphics field on the multi-boot header's machine state. Can't read what this says. It's too tiny. I'm going blind, by the way, if you all didn't know. Continuing. EAX must contain the value 0x2 bad boot2. Wait, but the multi-boot header is 0x1 bad boot2. Where's that? Right up here. The field magic is the magic number identifying the header, which must be a hexadecimal number by 0x1 bad boot2, because Ubuntu sucks. Then the field flags specifies features that the OS image requests or requires of a bootloader. Bits 01 through 15 indicate requirements. If the bootloader sees any of these bits set but doesn't understand the flag or can't fulfill the requirements, it indicates for some reason it must notify the user to and fail to load the OS image. Bits 16 to 31 indicate optional features. If any bits in this range are set but the bootloader doesn't understand them, it may simply ignore them and proceed as usual. Naturally, all as yet undefined bits in the flags must be set to 0 in OS images. This way, the flags fields serves for version control as well as simple feature selection. If bit 0 in flags were to set, then all all boot modules loaded along with the operating system must be aligned at 4 kilobyte boundaries. Right, that's important. I remember that. 4 kilobyte boundaries, right? We need that. Oh, my alarm is going off. It's 3 a.m. and we're programming some kind of OS. What? Okay, so that means you would need a 4 kilobyte boundary for your alignments. If bit 1 in flags were to set, then information on available memory via at least the mem underscore asterisk fields, whatever, I'm guessing a pointer or some kind, of the multi-boot information structure must be included. If the bootloader is capable of passing a memory map, the mmap pointer field must be, I don't know if that's a pointer. I can't say it's a pointer. Flags for if bit 2 is set, information about the video mode must be available to the kernel. If bit 16 in the flag were to set, then the fields are at offsets 12 to 28 and the multi-boot header are valid, and the bootloader should use them instead of the fields in the actual executable header to calculate where to load the OS image. This information does not need to be provided if the kernel image is an ELF format, but it must be provided if the image is in a .aout format or in some other format. Compliant bootloaders must be able to load images that are either in ELF format or contain a load address embedded into the multi-boot header. They may also directly support other executable formats such as particular AOUT variants. The field checksum is a 32-bit unsigned value, which when added to the other magic fields, i.e. magic and flags, must have a 32-bit sign or unsigned sum of 0. That actually makes it really simple. I didn't really understand this before because I didn't read any of this, so I didn't know what exactly makes the checksum value really. I was just like, oh wow, multi-boot header, right? Yeah, I guess it just works, right? But no, there's actually more to it than that. I was like, yeah, you subtract your checksum and then it just zeroes out. But no, that's not exactly the entirety of it, because you subtract this from this and this. So what does it mean exactly? Let's see. Which when added to other magic fields, which would be what are the magic fields? These are the magic fields. So magic and flags must equal 0 when checksum's added to them. So checksum, an unsigned sum of 0. So how does that work? How do you get to an unsigned sum of 0? Unsigned has no integer, like no sign value in front of it. What exactly does that mean though? Does that mean it needs to be back to 0x1 bad Bootu? Or does it have to be fucking 0, like nothing? I'm kind of curious because I don't actually know really. So that's interesting, but no, we know what we should do for flags, right? We need to get the 0. If bit 0 in flags were set, then all boot modules loaded along with the operating system must be aligned on page 4 kilobyte boundaries. Some operating systems. Okay, so we need to set that field though. We need to set it to 0. So we'll just put in why am I doing it there? 0? I don't know, but just Just slap. Actually, 0x. It's a 16-bit. I'm guessing I can just do zeros. That's 1 byte. You know, I could just do technically hexadecimal. Two of those would do 0x0 and 0x00. Is that how you do that? Am I dumb? I've never really done a I'm dumb. I'm stupid. How do you define these again? Wait, also, don't you need to DD these? Like, have them as DD? Oh, wait, no. DB is different from equals. Equals is for constants. DB is for something else, I think. But, like, that's a labeled DB. If we go back up, DB is assigning a value of some kind. DB percents integer value. DX, DB. DB is uninitialized, usually. Okay, scrolling. Declaring initialized data. Fadd. These are for floating point stuff for if you have an x86 extension. Label, instruction, operands, comments. Yes. Wait, would you label with a semicolon, or no, a regular colon? Regular colon. Yeah, you'd label with that. What would you label with that and then have it? I have no idea. It's clear I have no idea, but I will figure it out. And I know eventually we're gonna have to just the byte 0x55. 3 bytes in succession. Ah, there we go. So if I just were to do, well, for example, this is 2 bytes. So that means I have my 0x000 0. Alright, so the checksum then means we just have to have negative of the original, and then it adds together to make 0. Pretty much. I think that's how that works. So if I go back to the GNU grub guide, so you need to have the checksum is a 32-bit unsigned value, which when added up or when added to other magic flags must have a 32-bit unsigned sum of 0. Let me get out a calculator to draw that on, or somewhere to draw that, bro, because that's, bro, I'm never gonna remember that shit. Programs. Open up a GIMP instance, bro, so I can just draw this out. New. Okay. Alright, let's go ahead and draw that, honestly. I have no clue what this means exactly. Yes, the best drawings of all time. So we have our checksum. We'll just call it check, since, like, bro, how am I writing this good? Bro, I'm actually writing kind of decent, honestly. Oh, never mind. I'm screwing it up now. Checksum. And then we have our other fields. So we have, this needs to, then we need our sum. Unsigned means it just has no fields, and then, okay, so here we go. We have checksum plus fields, and then we get 0. So we need usign 0. That helps me understand it better. I hope this helps you understand it better. Nice. I'm a great drawist, if you will. Alright, so that's cool. Unsigned 0. So, I mean, 32-bit unsigned value. This is 32 bits, technically, because if you take, that's a byte. That's a byte. And then you have 2 more bytes, which makes a 32-bit. And then if this one's only 16... Isn't but fields can be 16 to 32 bits technically, which is kind of interesting. So checksum. Would we have to have checksum as a negative? I'm not even sure how you would do that exactly. Let's go over to NASM docs and see if they have that information. How would you just subtract it from it? Maybe if I read deeper in the GNU documentation, that's where I need to be. The address for the multi-boot header, machine state, and this stuff will be important after we get into its boot information format. Okay, here we go. Here's a pictures. I like pictures. Fix me. Split this chapter like the chapter OS format. Okay, thank you. Required present if flag 0 is set. So mem lower and mem upper. Oh, right, for stack, I think. Something for stack. So flag 0 is set, so if we have flag 0 set, we'll need to do that. Vibe control info. Let Grok take control. Oh yeah, Grok OS. Elon, when you gonna make Grok OS and send it to me, bro? I'm waiting still. The first long word indicates the presence and validity of other fields in the multi-boot header information structure. All as defined all as yet undefined bits must be set to 0 by the bootloader. Any set bits that the operating system does not understand should be ignored. Thus, flags field also functions as a version indicator, allowing the multi-boot information structure to be expanded in the future without breaking anything. If bit 0 flags is set, then the mem fields are valid. Mem lower and mem upper indicate the amount of lower and upper memory respectively. Lower memory starts at address 0 and upper memory starts at address 1 megabyte. The maximum possible value for lower memory is 640 kilobytes, and the value returned for upper memory is maximally the address of the first upper memory whole minus 1 megabyte. That's a lot to digest there, because it's like, well, it's like kind of like chained, bro. It's like a chained almost. If bit 1 is set, the flag's word is set, then the boot device field is valid, which indicates which BIOS device the bootloader loaded the OS image from. If the OS image was not loaded from a BIOS disk, then this field must not be present. A BIOS disk? So you mean like loading a BIOS? And yet again, we have met again in the middle of the evening to discuss Arch. Man, I'm just doing some programming, bro. I don't know. Are we discussing Arch again? I mean, you want to see my background? Have you seen that one yet? This one? Or actually, have you seen this one yet? My wallpaper is crazy, bro. I'm busy working on my OS plans. Frame buffers. Is that like to get you like VGA support? Who needs VGA support, bro? Like NVIDIA VGA support. We don't need VGA. We're gonna make it ourselves. We're gonna build the graphics card from C++. Oh, actually, that'd be cringe though. I need to read Cat V. Actually, no. Cat V. We read that on the weekends. Anyway, continuing on. This stuff isn't entirely important for me right now, but what are these? Four and 5 bits are random exclusive. Let's see, do they have an example of one? BIOS. Caution, the following items are not part of the specification, but are included for prospective operating system and bootloader writers. Example OS code? Nah. BIOS mapping techniques. This is actually a really good source of information, I would say. Notes on PC. In reference to the bit 0 of the flags parameter, if the bootloader in question uses older BIOS interfaces, the newest ones are not available. See description. Oh, okay. Then a maximum of either 15 or 63 megabytes of memory may be reported. It is highly recommended that bootloaders perform a thorough memory load or probe in reference to the bit 1 of flags. It is recognized that the determination of which BIOS drive maps to which device driver in the operating system is not trivial. Many kludges have been made to various operating systems. Lots of stuff. Example OS code, BIOS mapping techniques, IO restriction techniques. I feel like where I got last time was like the actual IO stuff, but again. Example OS code. I want to see the multi-boot header. That's what I want to see. I want to see how that looks at actually. Now this is written in gas. So now I have to translate gas into NAS. NASM. NASM, bruh. Fish OS soon? Bro, yeah. It will take me 10 years to make it good. So bad boots you. So define the multi-boot header magic. Yeah, well actually, this is written in C? Or is this just like, it looks like C, but it's really assembly? It looks like assembly though. It looks like assembly to me. There is an alignment thing too. This is the 4 kilobyte alignment, right? Okay. So here's a multi-boot header for us to look at. This is a good thing to look at, is examples of stuff that you can be like, how do I do that? So here we have, they define, and I don't know how that translates from that to the other thing. If and def. Oh, it's just define backwards. It's like, what are those things called where you like scramble up a word and then it's some lame shit, but if and def and define are just the same characters, just scrambled up. Hold on, I gotta drink some water, bro. Yeah. Like, yeah, I understand that. I've kind of messed around with this before, but I didn't really do a lot of reading or digging into it. I just was like, yeah, let me just copy this. I learned a little bit because I had to troubleshoot stuff, but it wasn't that interesting really. I was working with a D kernel version, or like writing my own D kernel, which we're gonna do. We're gonna do that. Basically, all you have to do is strip out all of the runtime stuff, and then pretty much just write mostly in assembly, unless you can get the runtime to initialize, which I didn't get that far. So, but a lot of the core features of D still work. Like there's a library called core. Oh, if in def if not defined, this stops the compiler from including it twice, since the compiler copies the header and source into one single file. Oh, okay. So this is to probe it, I guess? I don't know if we need all of the searching. How many bytes from the start of each file we search for the header? Oh, these are for like stuff like that. I mean, I guess you would also define your alignment. You'd also need to extern this, wouldn't you? Oh, you need to extern a few things. I remember externing a few functions from this into the D code. But yes, we'll need this stuff. I remember these things kind of. For now, we're just gonna work on getting like the header information set up, since it's kind of. So they have. What exactly was it again? Multi-boot info align, mod align. Ugh. Multi-boot header underscore magic. Bootloader magic. Oh, multi-boot memory info. Well, that's what defines for all of this stuff. Type def. It looks weird as hell, bro. It's just, bro, gas is lame, bro. I'm gonna be honest, the GNU assembler is not something I'm a big fan of anymore. After experiencing NASM, I'm like, bro. There's also a lot of code here. Oh, these are for video addresses, potential, or maybe? UINT 32s. This is kind of C though. Like, UINT 32 is definitely a C thing, I think. Isn't it? Defines are really just telling the compiler to replace the name with the value set. Oh, okay. So anywhere where there's a multi-boot info drive info, there's going to be a 0x080, pretty much. That's what you're saying? So we need to create multi-boot header magic. So let's go ahead and do that. We have our magic. Then we need to create our multi-boot loader magic. And I don't think we'll do these as equals, but I don't think we need that one. I'm gonna be honest. I think you only really need these 3, and that gets you into the OS. And then flags and probably an alignment one. Align, and then equals 0x, they said 4. Let's go back to the actual docs. Let's scroll up. Header align was 4. So how they do, what I'm really curious about is how they do the actual checksum portion. That was my first question. Now I'm getting into like a bunch of other things, but I see things that look like structs, but probably are not. What is a union? Bro, I've never actually used a union. Is that a D thing? Can I do unions in D? D-lang union. If we can make unions in D, I will have to make the fucking... Maybe? I've never actually really messed around with unions. Structs and unions. What's the difference between a struct and a union? Yep, anything that references multi gets replaced with, yeah. It's so memorable though. 0x1 bad Ubuntu because people who use Ubuntu suck. No, actually no, just Ubuntu sucks. Not the people who use it. I can't hate a person, but I can hate something that's shitty. Where am I going back to? Multi-boot specification. IO restrictions back up to here. E flags. Header addresses. Magic and this. Checksum. Let's go back. Here we need to go back down so we can just look at how they do that multi-boot header check. We might also go and check out OS dev, but I don't really want to go there and see all that. Oh wait, here we go. This is the actual boot file. So all of this was like just for a header pretty much. They have a entire multiboot.h, but it's written in C basically. Nice. Well, cool. We've seen that. We've read that. Anyway, scrolling down. Oh, we've seen this and we've read this. Congratulations, guys. Define ASM file, include multiboot.h, which is just saying that it needs to like grab this entire thing that we just looked at. So all of the defines and things in there. And then you have to do a linker step. I don't know if they listed the LD. Do they have an LD step for this? No, they don't even LD. Maybe linker isn't really required necessarily. I could be wrong, but maybe it's not required. Well, actually, I take that back. I see sim and I think symlink, so maybe it might be mandatory to do that. Oh, here we go. So we got some assembly going. And start's like your entry point, so you would declare like start. Well, you'd really just do like underscore start. If you're doing the linker, that's gonna usually be like underscore start, isn't it? You'll be like global start at like the top, and then boom. I'll have to read more of the massum docs to figure that out. Then here's the multi-boot header though. This is what we'll define, or a label for it. Multi-boot header, and then Gas does it differently, and they just use how they defined it before. So this just links back up to the top. Then we go down and we have multi-boot header magic plus multi-boot header flags. But it's gotta be negative. So it's gotta be the inverse of the first two, pretty much. Okay. So that if we're defining it up here. Wait, what did they just or I'm dumb. Checksum 0x. Actually, it would just be magic plus flags. Literally the same thing, I think. And then you just do 0x or magic minus flags. Or no, plus flags. So whatever these two are, it will always be the opposite. And I'm sure it's actually a valid declaration. Let's see. And these might have to be done as DD or DB or something, or yeah, DB. That's like the one that you should use for this. DB for just regular stuff. And then all this is for like special stuff. Scrolling on. Oh, yes, you can do this. Can you subtract, though? Unless, if we can't do that, we declare it in a different way. This is going to be multi-boot. Header. Colon. And all of these get shifted over. Pretty sure that's how you would define that. Then you would need an alignment as well. And global start. This creates an entry point for the linker. That part here. I remember that kind of. So continuing on. Including external binary files. Files.dat. I think you can do other ones, though. This can be handy, for example, including graphics and sound data into a game executable file. It can... Bro, you write a game in assembly, you'd be insane, bro. If you write a game in assembly, you level up 10,000 times, bro. Anyway, continuing down. Repeating instructions or data, 0 buffer, buffer, effective addresses. An effective address is any operand to a instruction which references memory. Effective addresses in NASM, so like a pointer almost, like it references memory, kind of points to it. Interesting. Anything not conforming to this simple system is not a valid memory address or memory reference in NASM, for example. Oh, it wouldn't make a copy of it though, would it? It'd be like referencing is not making copies. Bro, learning assembly is super important. I'm not sure why I've never decided to actually just deep dive into assembly for an episode. Some forms of effective address, like EAX is an address. I think there's some other ones though. There's a lot to read, but constants. Can't you declare it as a const or like something like that? Character strings? I don't think I need that right now. String constants, Unicode strings, floating point constants. Expressions. Boolean or Boolean XOR. Bitwise. You know what I want to do? I want to write an OS. Well, not an OS. I want to write assembly code so I can make an entry point for ARM assembly code. Sounds dumb, but I think I could probably just make a machine that just VMs ARM assembly so I can make it easy on myself, bro. Just be like, yeah, I don't want to write x86. Here we go, local labels. So you have a label, then some code, and then you do a dot for lower label. So like actually, oh, sorry, this is my horrible drawings from earlier. Todd's gonna judge me for getting rid of it, but. So you'd have your multi-boot header, right? But maybe we don't have it as a label, we just had it as like a dot. You also do like extern, but anyway. With global start, and I guess I could put a dot multi-boot header under global start, and then, but that would be like, it'd have to be under start. Global start, right? Label, some code, some more code, and then you can jump to a label. This is really important for loops. Like you'd literally just be like, all right, do this, and then jump to loop. Maybe I should start by writing like basic assembly stuff. That's what I'll do later today. I'll just work on some like low level or some practicing and stuff. Infinite loop trick. One of the ways to quickly implement an infinite loop is using which evaluates the current position in the code. So a one-line infinite loop can simply look like jump and then $, jump $. Jumps in mixed sizes, far calls and jumps, far intersegment calls and jumps by means of the syntax call segment, where segment and offset both represent immediate values. So to call a far procedure, you could do either of the following: call and then call. NASM supports no convenient synonym for this. Well, you could invent one of the following using a macro processor. 64-bit absolute jump, jump ABS. Wow, I've never even really seen that. Optimizing jump lengths and sizes. Bro, this is so much stuff to learn, bro. There's a lot here. But that's okay, I'm ready for it. About ready to get into this stuff. APX, Advanced Performance Extensions. Extended General Purpose Registers. Suppress modifying flags. Zero upper. Bro, we're digging really deep. Push and pop. APX variations of the push and pop instruction informs the CPU that a specific push and pop constitute a matched pair, allowing the hardware to optimize for common common use case. Operates on 2 registers at the same time, push 2 and pop 2 with paired variants, push 2p and pop 2p. These extensions apply to register forms. They are supported for memory or immediate operands. I have no idea what I read. I feel dumb. Continue on. The NASM preprocessor. Wouldn't this be like called... Oh, actually, what is this for, though? Macro processor. There's a C preprocessor. What is a NASM preprocessor doing? Anyway, let's write some basic assembly code just to get our head in the door, because this is like really blowing my brain cells out the window. Like they're leaking right now, bro. They're just draining from my skull. This is a lot to understand, but we won't understand it if we don't do the basics and try to figure out how to get hello world in the terminal. So let's go do basic stuff. Say that. Control S and save this to my delaying, and then bad OS with system B for bad. System B, bro. Get ready for system B. It's gonna be bad OS. It's gonna be so bad. Anyway, back to it. New. We're gonna write a simple loop program, I think, to start off. We're gonna go ahead and get started with a label. And then we'll call this program from delaying. We'll extern it, probably. Wait, is there extern? Control F, extern. There's 141 different extern. Inc bin. Wouldn't you have to extern it? Like extern? Let's scroll through all the externs available. Yeah, there is extern directives. Where's directives at? Those are important too, though. Those are like very important stuff. Tells the assembler what to do, I think. Percent line directives, directive processing. Oh, it's all in the preprocessor then. So go down. Let's go back to where preprocessor was. Preprocessor time. Oh, I'm allergic to fucking assembly code. Oh my god. It's in the preprocessor floating point constants. Preprocessor, where are you at? Where you hiding at, bro? I just saw you preprocessor. Oh, here we go. Expansions, which this is all important. Comment removal. Line directives are preprocessed. See section 5.14. The number of pi, but if you had 5 pi's, it's 5x the pi. Inline expansions and other directives. Multi-line macro, detokenization, preprocessor caveats. Okay, scrolling on. Oh, okay, here we go. Yeah, my allergies are kicking in right now, bro. You guys can probably tell I'm so fucking allergic to this fucking multi-boot header, bro. Define. Invoke another macro. The expansion is performed at invocation time. So you could do define param a comma b, a plus b, or a plus a, b. define foobar. This doesn't prevent single from being redefined. You can perfectly well define a macro with define foobar. Percent define for foobar macro. Macros, bro. I'm getting my macros with my assembly code, bro. Oh, that's cringe, honestly. Single pair parentheses. Yeah, I think this is resolving define. Define. Is true 1. Is false. Is true. Is true 0. Lots of define. Define many. Concatenate. Alright, let's go back up. Actually, might be here where we can actually do the whole extern thing. Keep going down. Because I know directives are important for the thing, but then how do you extern, right? Like, yeah, you can include... Oh, I define single line macronym. So wouldn't these just be like a way of enumeration, basically? So like, you could define things and then have them... My brain is melting. Dude, I swear if I get another ways for... I'm gonna throw a chair. Bro, I understand that. Bro, I'd throw a chair right now too. Also, how's the programming going? I'm kind of just lost in assembly land. I think I've dived too deep. I think I need to go back and start from the beginning, honestly. I'm like, yeah, there's all this information here, but like, I'm so deep in there. I need like an assembly example of like the formatting, honestly. And then I can figure out what all that does from there. Like I feel like these docs are great, but me, I don't know. This is kind of something I struggle with. This much information is like overloading my brain. Oh, there might be stuff in here. ELF32, executable and linkable format object files. Okay, so I think we need to get down to like 9.9. Mako and Mako 32. Macho? Like macho? Object files. But ELF is important. Embedded file dependency. DLLs. Which are like dynamic linked libraries, which we use those for a lot of... We use .so, which is pretty much... .so is Linux. I can definitely understand where you're mentally at with that, lol. Took computer science course and decided hardware is my go-to. I can do hardware mods, just not programming. I'll leave that to my bud. Yeah. No, I like hardware too, honestly, but like, this is a lot to dig into. Honestly, I just like all technology. If you just were like, Fish, make a video on this, I'd be like, damn, I should definitely do that. It could be like anything. I'd be like, oh wow, GPUs, I'd do that too. Programming, do that. Just gotta, I don't know. I just enjoy it. It's fun. Fun for me. Definitely a great thing. Strict inhibiting optimization. Alright, so here's bitwise stuff. Defining constants. Oh, pseudo instructions though. And that's res b and friends. Declaring uninitialized data. Okay, so that's why that was important. Suggesting then video or modifying the original Xbox One launch model when it becomes publicly available. If I can get my hands on one, I'm not sure. I'll have to look out for that. If I can get my hands on that off of like eBay or something. I also don't really have much tools, so if I have to do like a lot of like soldering, I'd have to go to work and then solder there. That's where all the soldering stuff is. So that wouldn't really be great, but I'll see. I think the most I've done is build a cardboard box PC, honestly. Let's see if there's NASM examples. NASM tutorial from LMEDU. This tutorial will show you how to write. I'm sorry, I'm too blind to read that. I need to like make it mega. Please make this page mega for me. Please make it mega. Like 150%. They've been decently priced. Picked up a COD Advanced Warfare model on the list of vulnerable models for around 80 USD on eBay a couple months back. Yeah. eBay is pretty great for pricing and stuff. Here we go. That's my multi-boot stuff I need to look at. Global start, which is to declare that the label start is an entry point. I'm guessing that they then either run this or structure of a program. Here we go. Breaks it down too, bro. This is actually a great guide. So global start, then it breaks it down into this, and also section.text is like declaring some kind of each of these are different. Oh right, these are important too, because you have a section for text, you have a section for data. When you go to link those in an ELF format, one of those is going to be row data, where it's read-only data. So that's interesting, because I kind of remember bits and pieces, but I don't remember the whole thing. I'm just going to try to go from nothing to remembering the whole thing. The NASM manual, the Intel processor manuals, which are like, bro, you click on this, you go here, you're going to see 10 billion fucking pages of docs like this one. It's just like the AMD docs, but like it's fucking huge. Put that in my documents folder. Do I have a documents folder yet? No documents folder. Oh, do I have one? I just save it there. Sure, why not? Then I'll open it. I'm gonna open that thing, and you'll just see fucking 5,363 pages. Yeah, it's got the 1 terabyte SSHD drive, so it's a hybrid drive. Still gonna replace it with an SED when the prices fall. Also, I wish our course was broken down like that. It would have helped a lot. Yeah, that's like a really, like, how was it? Where was it? This is a really good breakdown. Like, I like that it's kind of grid. So you got your labels, instructions, operands, and then you have your directives, start that, and then you have sections afterwards. Which, GAS does the directives differently. I've also read ARM assembly stuff and done some videos on that, and also pretty interesting. System call for write, file handle 1, then move RSI to message. The address string to output, number of bytes, and then the message is done using this, which is a pseudo instruction. Is what it was called? And I guess pseudo instruction is important. So we need to create a global start, so our entry point exists, which I already have done. So that's pretty much good. Then we're gonna put that on top of our instructions, pretty much, which is our directive. Global start. No need for a colon, because it's just gonna make the sign start into a global. Then we'll probably need to extern to actually call it from another program. But if we don't call it from another program, what if I wrote the whole thing in assembly? I feel like that'd be a good place to start. Also gonna be doing dishes, but still around. Sorry for flooding the chat, by the way, lol. This is cool. I need to get back into programming so I can try to make my own tools for modding. It'd help a lot. Oh shit, wrong tab. Let's see. Section.text. So I got section.text. Right. So these will be done with the linker when we create our ELF format. Which I probably should go read about that. It's okay though. I'm gonna do a lot more reading later today if I get time. I probably will. I hope. Hopefully I get time and I don't just get fucked today. Probably will get fucked today. Pretty much. Section.text. But with the it'd just be like multi-boot header. I mean, there's only a few sections you can put in one of these files. Start : move. But that's for when they get to that. We also need different sections for CTRs. I don't have my example code on this computer. I could copy my example code to this computer to look at it, but and ld hello.o with a.out, which where do they create a.out? Oh. Structure. Generally, you put your code in the section .text and your constant data in the section .data. Cool. So we're gonna create section.data. Section.data, and go back to here, right? So we have section.data. Section needs to be aligned in the instructions column. I'm pretty sure that's like 2 tabs, 3 tab. It should be aligned with equals, pretty much. Yeah, why not? Sure, that looks okay. And then put our start label somewhere. Start's the entry point, so start will just be my multi-boot header. Start, : and then figure it out from there. So they have move right after start. However, if you have .data, you wouldn't. Would that wouldn't be your start, would it? No, start wouldn't be .data. That'd be. We'll just call this multi-boot header still. Or data, one of those two. Multi-boot _ header. And that's really long, so I'm just going to call it the mboot header, just to simplify my life. Okay, that looks much prettier. Part of programming is making it look pretty. Section.text. We have section.data. And then we're just going to move all these up to the lines. And these are definitions of the things, pretty much. Why would you would have to label it DB data? That doesn't make much sense. So these are just sub-labels. I guess if we did it this way, these would be my labels. And then my global goes on that line. So it just lines up with this. So this is how that looks. And then you do this to get to your magic plus flags, I guess. Then you also need one for alignment. And you might want one for the 16 kilobytes to create a stack. Syscall move XOR and then continue. Your first few instructions. There are hundreds of instructions. You can't learn them all at once. Just get started with these. Invoke an operating system routine. What the hell? Bro, that'd be cool. Invoke a sys... Bro, what if we invoke the reboot syscall? Syscall reboot. Syscall reboot -h now. Each 128 bits wide named... What the hell? Study this picture, hopefully it helps. Yeah, Bro, I like pictures, bro. You know I like pictures. I learn a lot from them. 128 bits. That's where big int comes from, bro. Big int. I'm telling you, that's where the D-Lang big int comes from. Memory operands displacement only. This is a good reference, but that's actually really neat. 2 memory operands are really rare. These also need to be done as dB. They're not constant. They're not going to be like a constant thing. Control S. Then we need to extern. Global start, section.text, start, labels, lots of labels. Using a C library, and then you extern. And puts is for like, isn't that for like writing to the screen? But anyway, extern is important. This is a word that we will need. So if the global is main, then we need to extern our program. So let's go ahead and... So global start, and then we'll extern the things that are important. For example, CTRS and like things like that will go in here. But basically you extern a label so that way it can be used in another language that's higher level, like C or C++. I'm gonna make these align better. Tab. Then save. Alright, so that's cool. Extern puts, and then section. We're going to start with section.data because it's going to be kind of important to start like that. In Mac OS land, C functions or any function that is exported from one module must be prefixed with underscores. The calls. I'm surprised you can run that on run NASM on. I guess it would just be compiling an ARM assembly file, I guess. Because isn't Mac ARM kind of like, but super proprietary ARM? Like, they probably still have to pay like to the ARM people, bro. ARM's kind of proprietary, honestly. But yeah, we'll extern start. And say we have global start and we extern start. Actually, wouldn't you extern your boot header? Where is my boot header? It's supposed to be colon. Oh, right, those are different though. What the? Section.data, multi-boot, colon, maybe like this. That might be the best way to do it, and then space these ones onto the same line. Alright, that should be good. And then save it. So that gets us to here, which means we now are... But these are labels, though, and then we're just doing DB on them, right? Like label DB. See, they just put a colon afterwards. Maybe I'm wrong. Or unless I wanted to do dot magic and dot flags and dot checksum, because you can do the sub labels, as we saw earlier. That is an option. Section dot data, understanding calling conventions. Because you can do a sub label, right? Push, pop, and return. And then here's C. We've called ARM assembly from dealing before. It's something they've done. But x86 or using NASM is just like different, because I was using regular GNU assembler. I was like, bro. So yeah, just do colon and slapticate a colon there. It just works. Section dot data. Here we go. Looks like I'm correct in my assumptions. We have to slapticate a colon on all of these because, yes. And checksum exists, so now I have flags, checksum, and pretty much everything. Save it. Now all I have to do is go further and then add another section, probably. Section dot text. Bro, it ain't aligned. It's making me go crazy. Why is it no aligned? Dot data. They'll do dot text. Section dot text, which is gonna be like the main stuff. Oh, we also need to initialize or create some kind of alignment. Let's make it lowercase. Align, and then db 0x 0 0 0 4. Should be like that. Something like 0x 0 0 4. Something like that. I believe since the label is at a specific point in memory, it sets the bytes there. Yeah. I think. So we have this. I only remember needing like 4 things for the multi-boot header. I just really don't remember much. Also, when we were reading the GNU docs, it said we have to set memory. Oh, memoline, maybe. No, something like that. That's something else we have to do. Let's go back to the GNU docs. They have a multi-boot header docs here. Let's scroll back up because this is not going to help me. I need to just read what they have inside their multi-boot again, because we have to do stuff with the mem. So if you define the magic or the flags as 0x0, then you need to have like, or have like a something with it. The 0-bit system must be aligned on 4 kilobyte boundaries, which I believe is 0x 400. Could be wrong. 0x400, right? Yeah, maybe. Let me use my brain cells later. We could just go to OS Dev and see what they have going on. OS Dev, but is this cheating? This is like cheese, bro. I mean, I've tried, so let's see. Cause I mean, we'll learn more by just reading and. UEFI inline assembly. Wait, inline assembly. The idea behind inline assembly is to embed assembler instructions into your C and C++ code using the ASM keyword. When there's no option but to use assembly, sometimes even though C is your language, you need to use some assembler code in your operating system, be it because extreme optimization needs or because you're implementing. I think we've read this before. This is very familiar. This is definitely familiar. Assigning labels. Using C99. Anyway, back. What? Continue. Spyware. Required knowledge. Getting started. Let's go. C# bare bones. Oh god. I have a friend who wrote an OS or is writing something in C#. That's what I'm missing. This is pretty much all I need, is this thing here. Although, this is... Bro, C# must be really easy to... I'm gonna be honest, that looks really light compared to the D1. With the D1 you had to have... But I guess part of it is all you need for a C# OS would be to get into the .NET runtime. And that would make for a really interesting OS, because then you'd have a highly modifiable operating system that uses IL, intermediate language. I'm like, what? I mean, that would be interesting. Like, the implications are very interesting. I don't know. It's like, it'd be really easy to backdoor, I think. I feel like there'd be some security implications with it. That's the first thing I thought of. I'm like, damn. Building Tesla. This is actually really interesting. Let's just read this shit. What are we doing? Just fucking around with assembly and trying to learn a little bit of assembly. We will create a directory to build our OS and ISO file, and then making something like make dir-p barebones ISO boot/grub should suffice. Extern kmain, and this is like a typical thing you call it as a kmain. Also, they do their alignment way differently from how I've been doing mine. We'll just call this how it is, extern kmain. So we'll add an extern for kmain. And then we'll probably try to write it in VLang, bro. That's a terrible idea. I don't know enough VLang to write in VLang. Flags, module, align, and mem info. That's something I'm doing wrong. Also, I can assign them using EQ. Let's, and this is also correct. Okay, I kind of understand more than I did last time, though. Let's get rid of all of that. So it's a good thing I got myself started off with the warm-up of assembly code. The warm-up as in hell assembly code. Magic the Gathering. Magic. Oh, and those are all caps. Global tab underscore start. Then you have extern kmain, which is what you would in the dlang one. It also did the same thing. You also have module align, and you set these using equals, which is what I was thinking to do originally. We'll also need to come up with a system, but we'll see if we can get this to boot a D-lang kernel. Since D-lang is kind of similar to how you would do a C++ one, you need constructors and destructors in your linker script and stuff like that. But I don't know if that's required. If it's not required, why would I implement such a thing? I could probably just write the whole thing in D by just writing it as extra in C. And, I mean, then you limit yourself to not being able to use some features, but anyway. These are bitwise to do God knows what, but I think that's an alignment to the left by 1 bit. So we'll do that. Module align, and then it goes 0, or actually 1 to 1, and then actually this should be equals. Those are good, I think. Let's see. Also, we can just technically do these without spacing them out. Like that. Here they do the first one's 0. But that's the 2 things you have to do, right? Because in the grub documentation it said you had to do 2 of these. Mem info equals 1 and then 1, and then the next one you had flags, right? And the flags, I think they're just setting it to 0 basically. Let me see what they're doing in a second. Flags go up and set it to equals. Flags equals, and then module line and pipe it, so or it together. So they're ORing together the 2. So I wonder what that actually does under the hood. And mem info. Let's see if there's a NASM. Bruh, Todd. Get out of my stream, Todd. Okay, NASM. Oh, yes, there is. There definitely is one of these, but I am not sure I see a net-wide assembler. Intel x86 NASM. I guess this is what I'm looking for. Because it makes it really easy to read. Makes it really nice. That's why I like Kate, bro. Kate has the nice fonts and stuff. I'm so sorry for using Kate. But it's that one guy who was offended yesterday. Upsetty. So that now you add magic and flags together in this one to create a inverse of the 2. So if they're variable, like you change it later, it just automatically does that. But that's for flags. Checksum. And then you just do equals. And it's gotta be 0x1 BAD B002. AKA bad Ubuntu, as in Ubuntu sucks, and my OS, bad OS is better. Bad OS is going to be perfect because it has a multi-boot header that contains bad Ubuntu. Perfect. Bad. It's got the word bad in it. I like it. I don't know. It's just memorable. It's I don't know what it is. It's because Ubuntu sucks, bro. Magic. Oh, but that's not my checksum, that's my magic. What am I saying? Magic. The Gathering. Checksum. So then I have my checksum, which is just going to be a negative. It's going to be inverse of flags plus, and I don't think it matters because it's addition, but flags plus magic. So what happens here? Let's go ahead and try to break this down. First, it looks like a left shift by 1. Although, it could just be ORing or like shifting in a 0 or adding a 0 or something along those lines. But this is not defined as like what exactly it's doing. Although that is piped together to create our... Potentially these are like byte. Let's go read NASM docs to figure out what that's actually doing so I can understand it better. Because there's a section on bitwise operations which will describe what that does. Command line syntax. My computer is super hot. Nice. Programs. Xterm. Xterm, please watch the sensors. Fuck. There we go. Look at this. Comes with a lot of sensors. Nice. Thank you, Intel. Intel. Bro, if Intel ever is like, bro, fish, we could sponsor you. I'll be like, Intel, thank you. That'd be amazing of you to do that. Someday we'll be there. We'll be like Dell sponsored, Dell funded. I'll be a member of the Dell team. That's what I want to do. That'd be amazing. The NASM environmental variable. NASM. Here we go. Those are reference to cover this discussing stuff. Bunch of stuff. 3 is where you get to the noob section where you're just starting out. Pseudo instructions, which includes res B and D, which res B was important in the D one. Although we're gonna try to just make a pure assembly one, I think, or maybe assembly and then try integrating other things. I feel like high level languages kind of abstract it too much. Really, what's going on under the hood is just assembly at the end of the day, anyway. It's just really, really interesting. I wonder, also a lot of different compilers build their backbone around, like, you know, different, like, you have options. There's lots of options nowadays. Like, there's so many options out there. There's GNU environment, there's the LLVM stuff. You got your NASM assembler. I wonder if you could have, like, a compiler, a C compiler, and be like, alright, I want a C compiler that compiles with NASM, just because I like that environment. Or like, I wonder if there's like ways to do that, like you can swap out the assembler. I know you can change linker. I've never really thought about changing the assembler, but I've used only like 3 different compilers for D-Link stuff. I've never really messed around with C too much. The C atmosphere, how many C compilers are even existing? I feel like C compilers list. I want to get a list of C compilers. Oh, list of compilers. Here we go. ATA compilers. You have GC. Oh, yeah. GNU is pretty much covering everything anyway. Tandem computers. Windows, no. Unix, like. License type is proprietary. We hate proprietary. That's evil. DOS. Oh, you know what's also cool is 16-bit OSs. When I was reading on the one page, it was like 16-bit OSs, I think. Bro, this is so fucking cool. Algol. How many Algol compilers? Purpose military? Lots of those. Well, actually, makes sense because Britain was in the computing game like first, weren't they? They were kind of in that game first, honestly. Because they had the Turing guy. Bro. Oh, Intel 86. The A86 assembler, proprietary. Then you have the FASM. I feel like this one has the most... Oh wait, those are assemblers. Those aren't compilers though. I guess it's practically the same thing. But the thing with an assembler is like the language is also different. The Microsoft macro assembler. Proprietary. I'm gonna get that on my Linux, bruh. Trust me. Net wide assembler. BSD. And then this one's GPL3. What is FASM though? FASM is an assembler. Supports Intel style assembly language. Motorola 68. That's a thing. Zilog. What are these, like Russian assemblers? Zilog sounds Russian, bro. Zilog Z80. What's a Zilog Z80, bro? Why can you assemble for it? Maybe it's like Verilog? 8-bit microprocessor. So like early computing. That's fucking cool. So like early days. Kind of interesting. I'm getting distracted. Basic compilers. Bro, basic is like super covered. I mean, it's been around for a long time. You know what runs basic really well? Here, let me see if I can get it. I have something. This will run basic really well. I've been thinking we might program on this because there is documentation from TI 83 plus docs on how to write basic for this thing. And this thing's like crazy. I feel like they're just really fucking cool calculators. I had this when I was in high school and I would just write programs all day on it. Because, you know, besides reading chemistry shit that I would just pirate, I mean, what else am I gonna do? How else am I gonna get smart, bro? Basic interpreters. You can interpret it as well. C compilers. Now here's the heavy hitting stuff. Proprietary. Well, we'll just look at the open source ones. CH, freeware. That's fucking... Wait. Oh, it was made by Solaris? Oh, wait. Are these like the... Oh, operating systems. Oh, okay. HPUX. I wonder what the history is there. I'm sorry, I'm just nerding out now about assemblers. GCC. Digital Mars is interesting. Because Digital Mars was involved with D. Because they made the DMD compiler. Digital Research C. And this might be linked to the guy Walter Bright. He's written assemblers. He also wrote D language, pretty much. I don't think he entirely did it himself, but great engineer of all time. Interactive C, freeware, ANSI C with several libraries. Open64, portable C compiler, quick C, small C. I think C lang is in here, bro. The amount of C compilers though is insane. It's like innumerable. XLC, AIX. That looks fucking cool. That looks like a cool OS, bro. And C++ compilers, and then you got your C# compilers. Now this is where it gets interesting. IL2C++, IL2 CPU, head of time compiler for .NET that is written using one of its common intermediate language. It is BSD license. They're also forgiving ILGPU, but I don't think that's necessarily a compiler. It actually is, I think, though. IL to C++. Bro, the C# ecosystem is crazy. IL2 CPU is an ahead of time AOT compiler for the .NET language that is written. Bro, I'm gonna have to open this up and bookmark it so I can research it for a video later. We owe you an explanation. Guys, you know what I'm gonna do to this thing? I'm just gonna inspect it and hit a delete us on that thing. Delete Amogus. Amogus, Bobby. Kaboosh. Ah, I never saw it. It was there. Congratulations. I have developer tools. And then they banned developer tools. COBOL? I feel like COBOL's kind of lame anyway. Like COBOL, you just go, yeah, fucking lame ass language. Except for mainframe systems use COBOL still. D for .NET, which did exist, but didn't really go very far. That might be something to look at for a future episode. I wonder if I can get my hands on it, because I don't know if it's still even up on the internet. Diebel DBL compilers. Eiffel? Is this for like French? Like, oh, French compiler, bro. Gonna compile to French. Bro, but I feel like the C# stuff is the craziest. To bare metal machine code. So like, I gotta send that to my friend real quick. He's interested in this type of stuff. Still use COBOL? Yeah, I figured, because it's kind of that's where the business language kind of comes from. Here, let me just copy the link to this page and send it to my friend real quick. Friend, here you go. Paste. He will enjoy that, I'm sure. Alright, so continue down. He programmed C#, he would love that. Common Lisp compilers, D compilers, but D for .NET, that's something else we need to look at. Like, this would be a cool idea. Implementations, the most current D implementations, I don't think the D for .NET compiler, it is for D language 2.0. CIO bytecode rather than machine code can be run via common language infrastructure virtual machine. The project has not been updated in years. The author indicated the project is not active anymore. Yeah, I figured something like that. Uses LLVM. This is a bunch of different ones that I haven't heard of STC, but it's pretty cool. LDC is the best though, I think. I don't know. Never heard of SnazzyD. Also, this is out of date because if there's a SnazzyD compiler, where's STC in here? A list of compilers. It's not complete if you don't have STC. Continuing down. Fortran. Oh, I know a guy who writes Fortran. But anyway, XL Fortran. What's that? IBM? Cringe. Go. You only get 3 ones. The LLVM one got dropped, bro. They're like, yeah, I hate LLVM. I'm gonna just stop working on this. Haskell? I think you can measure how good a compiler is by how used the language is by how many compilers it has. I think it's a good measure. Like if you have, like Java, for example, 5 compilers, that means Java must be doing better than must be not as good as Forth, but way better than Lisp or Haskell, which only have 2. And then there's Fortran, but also the number of compilers could correlate to how many different places and industries and people have used it. Like maybe it's really easy for them to write a Fortran compiler too. Think about that. Maybe it's really easy to write these. It probably isn't, but still. Also, Oracle pops up a lot. Oracle's really interesting because they're like kind of like what is it? Sun Microsystems. I think they came from. Yeah, they owned Sun Microsystems, which made Java. So that's where Java came from. Also, Sun Microsystems made Sunfire servers and other stuff. So that's really cool for their hardware stuff. Although Java compilers, like it's compiled and it doesn't run in a JVM ? Like I have no idea about that. Maybe I'll hate Java developers less if it's a compiled language. Into platform independent bytecode .class files. Meh. Java's kind of fucking lame still. If you're translating it into fucking bytecode and not just putting it into the fucking thing, it's not that cool. Into assembly. If you're putting it into assembly, it is cool. Big cool. I like assembly. Assembly big cool. PL/I. Python compilers and interpreters. Iron Python for common language See, here's the thing, is that like I really wish D-Lang had a .NET compiler, because I would really get into the .NET ecosystem then. But I cannot do that because D-Lang does not have that. Plus, why would I want to get into a... Maybe I'll just ask my friend to make a fucking D-Lang to .NET compiler since he's in that ecosystem. Maybe he could do that for me. I don't know. I don't expect anything to come of that. Rust. You only get two options. The Rust Foundation one and this one. Other OSs? Good. No other OSs, please. Bare Machine? Oh, that just means you can target like a bare machine. Scheme. Oh, wait. Does the Java section have bare machine compilers? BCL. Binary code license. I'm guessing blue is for evil, since proprietary is blue. PyPsycho. Scheme? What the hell is Scheme, bro? I've never even heard of that. Smalltalk? I think I've heard of it once. Command language. Both proprietary. I'm guessing for something interesting. I'm not sure what they'd be used for. Rex. 2 proprietary, 1 CPL? What is CPL? CLI compilers. Oh, for common language interface, maybe. Or, I don't know. Common language intermediate? It's one of those. Visual Mono Portable .NET. Inactive. Delphi Prism. Rose. 3 Libre source research compilers. Oh, is ILGPU listed in the research ones? Anyway, it's really interesting though. This definitely isn't a comprehensive list, because there is a shit ton of compilers. For example, Fortran might have the most, I think. Well, I actually take that back. C++ has the most because it's the... Oh, and C. Obviously C. Basic has a lot. Basic has compilers and interpreters, so... I mean, that's pretty neat. Ada has a few. Anyway. That's a lot of different things. So anyway, back to this. So you get to your section.txt, and then you have a keyword, or whatever the hell this is, a line 4. Then you have DD magic, DD flags, and DD checksum. But here's what I think happens is, in this is like the macros, right? The macros that exist. So you do all this before anything else. Either there is no section for this, or when they get to the linker scripts, which down here, you see .row data will apply to this section. And this .text align here, this is important to know your linker scripting and stuff, because these are going to be important for the different sections. So you see a .text, that's going to go to this .text. Then you have the BSS, that's for your stack. Data is for the data section. So when there's a data section, that, I guess that points it to that. I don't remember what exactly this is for, although I know these are alignments. Oh, these are probably just aligning it to like kilobytes or something like that, or something along those lines. Just keeping it all aligned. This is to default your start entry point. So if entry doesn't actually work out, then it will just default to the dot equals whatever the entry point is, and that's where it's going to go in the code, or something along those lines. So section.text is aligned here, and the entry point is start, so the linker will make the entry point start. And this is when you're compiling an ELF format. So let's see what we can do. We're gonna create our section dot start. No, section dot text. Do that, and then we'll continue down. You need to make a line. Is it capital line or what was it again? It was like 0x1 something. Oh, it was just fucking 4. I'm an idiot, guys. I'm so sorry. I'm Canadian today. All right, and then so after you've aligned it, then you just continue down and then go to here. This is weird. I've never seen S throw, but this looks like to me a jump halt kind of thing. So you would get stuck in this loop, and this is where a lot of it just stops. So it holds the CPU when nothing's happening. Pretty much just halts the CPU when nothing happens. Although, how does the kernel like even run? Brain power is eluding me at this time. Then we have DD, magic, and flags and checksum. So because they're defined up here as constants, then all you have to do is put DD in there. What does DD mean though? That's the real question. And so let's go look at the NASM docs real quick. Where's NASM hiding at? NASM? Where's my pseudo words or whatever the fuck they're called? Pseudo? You got your pseudo words? Pseudoers. Somewhere in DB. Resb and friends declaring uninitialized. These are for 16 dupe or something. Well, I'm sure there's a section where it says what DD is. DD is multiple. Oh, okay. DD is just multiple bytes, I guess. But although you could technically do the same thing with, oh, well, it has to be DD. So it's just to declare multiple different bytes all at once, I guess. So that's just a more efficient way of writing it, I guess. I mean, for this case, it makes sense. DD for all of those. So DD for flags, magic, and checksum. In that order, because it's the order it goes in the original thing. Flags, DD, magic, and DD for my checksum. And save it. Oh, you know, I gotta show you all something. Since we just got to this point in this tree, since we're like close to 5 a.m., let me show you all something really interesting. So you remember yesterday how we tried to add to Thunar something really interesting? Well, I actually got to work apparently, and now my Thunar instance has fucking RGB bullshit going on. Wow. Thunar, bro. Thunar is now fucking vertices. It is as good as vertices. What are these? These are like my tests, bro. Those will blow up the audio and cause a massive explosion. It only applies when you're hovering over it, when you have it selected. So check the temps. What's the temps be cooking at 62 Celsius, bro? Alright, we can up that to 2,000, bro, and then watch as it catches on fire. My next goal is to just RGB shader this stream. Anyway, need another section for dot. Wait, but wouldn't this be in a dot data section? Wouldn't you want that in dot data? And or potentially dot row data. We got S throw. So they're just executing this? I mean, I guess that makes sense. But this is the linker script they used. Ugh. Man, this is the most bare bones you can get though. So you would do probably something along the lines of start here and then just keep Well, actually, the global is start, so it will just go through the whole thing. Probably. Unless I'm misunderstanding that. Go back up. S throw, and then halt. And jump S throw. Really? We're just gonna put it as CPU halt. Wait, what's S throw though? It's nothing special. CPU halt. And that's a section, and it's gonna have halt, and then it's gonna jump back to CPU halt. So, JMP CPU halt. That's literally all it does. So that should be enough to get us to boot a system just with this. Although, will this work? That's the real question. So let's go into my folder. Let's open Thunar and go into the folder. Yes. Take me to the D-Lang folder with my bad OS that I'm slowly making. Let's rename that to, from global start to, oh my god, look, it looks better on that, honestly. I like it on the tiny ones. The tiny ones look the best, bro. Anyway, global underscore start. Let's go with call it what it is and call it boot.asm. We should be able to just assemble that now. So I will open up my terminal programs, open this thing. Let's go ahead and do cd d-lang and then bad OS. Then we're gonna go ahead and make our boot ASM and test it. So we need to do nasm-h should give me a list of all the things. I think there's one that creates an ELF. Yeah, we'll do -f. And then there's a couple ones. Let's go back to the nasm-f equals, I guess, select an output, c-h-f, which gives you a list. So then you can do your format. So here's ELF x32, ELF 32, and ELF 64. And ELF 32 for a x64 version. That's actually what the x32 is. That's pretty interesting. So we can, and ELF is for something to do with linker files. So when you do the linker script and stuff, ELF 32, and then we need our files. No input files, and you probably need an output file as well. Let's go with boot.asm, and then the object.o. So let's go with just a .o file, or maybe we'll just compile it to raw. Yeah, it created a boot.o file. So now to actually get it to the next step, you need to use LDC, and something in here, we're gonna have to write our actual D-Lang code for this using a lot of extern C. But I think we'll probably save that for next time, because I really want to wrap up today's episode here. So I'd like to thank you all for watching. If you all enjoyed today's episode, I don't know. I'll see you guys next time, and goodbye.